Hello everyone, as mentioned, I'm here in Ottawa for the CIO CISO Summit by CDM Media, and I had my chance to go up on stage a little while ago and present the AI trust framework that I've been discussing and sharing online. And so I'm going to share that presentation with all of you, and I'll overlay the actual interacting with the prototype proof of concept tool on AI trust that I created. I hope that this is helpful for you to understand some of the fundamental steps on how to build AI agents that are trustworthy, and that you have a means of communicating and sharing the trust, the degree of trust that you have as part of an enterprise or production deployment for your organization. So keep these concepts in mind. As always, I'm happy to discuss them with you if you've got ideas or insights. And I'd love to know what you think about this exercise, if this is a helpful way for you to understand, or if you would like to see some different aspects of how to implement these systems. Please let me know, and we'll kick off the next series shortly. But this will wrap up the trust series, and then I have a few fun things planned next. So check out the presentation. Hit me up in terms of what you think of the topic and how you might apply it in your organization. And I'd love to hear your feedback. So let's go. So thanks everyone. The intent today, I'm going to walk through a presentation. I think I have about 25 minutes, and there's 17 slides, so I'm going to keep it somewhat brisk as I'm moving through it. But in addition to talking through some of the R&D work that we're doing, I'm really trying to put forward a way of thinking about generative AI and large language models that you can take away and hopefully apply in your own organizations. One of the things that we talk about often is around the level of trust for these new systems. And that is a very difficult thing to quantify. We want solutions that are reliable, that give us the results that we're looking for, and that we have a high confidence in. And coming from a legacy of IT, we built systems that would work in a very reliable way without bugs, or other than bugs. But that would do a very specific task. And now we're getting into generative AI, and it doesn't always work the way you want it to work, just like people. So when we're thinking about trust in a system now, we have to reframe our concept of trust, and we have to come up with new metrics and new ways of thinking about how to establish that. So when we think about trust overall, not just about AI and technology systems, there's some terms that we may think of that. So what is trust? Is it consistency? You can trust something to happen. The sun will rise tomorrow. Is it accuracy? Right. So you can trust something to work, but that doesn't mean it's accurate or it's going to be doing a good job. Is it integrity? Is it doing the right thing? Or could it be alignment, which is maybe doing what's desired, whether or not that is the right thing? And so we actually have a hard time establishing a common consensus around trust. We all have more of kind of an implicit sense of what it means. In our lives, we trust but verify things on a daily basis. We check second opinions, we ask multiple people, we go to multiple different sources for information, different institutions, and what we build as individuals is the synthesis of many different sources of information brought together, and we filter that through our experience, our knowledge, our ethics, and we determine whether or not we trust things. And interestingly, in 2024, we live in an environment where trust in people and institutions and narratives is challenged in the news and media. You have a very polarized world, and so one thing that we do as adults, we check multiple different sources. We make our own. We look for factual sources, and we try to draw our own conclusions around things that make sense to us. But we have to apply that. And so a concept here, you're going to hear from different vendors who say, "Oh, I don't want to name a product, but we just talked about Copilot, so it's germane to the presentation." And I'm certainly not isolating them, but we talk about, go with my product, ChatGPT, Copilot, Llama, these other platforms and solutions coming out. But there's a concept here is trust in greater numbers. So when we're hiring in an HR practice, there's 3 people on a board. Why do we put 3 people on a hiring board? Well, because we all might make mistakes, we all might have biases, we all might have our own opinions, and as a group, we will likely do a better job if we compare results and come up with a conclusion, and that goes back in the hiring decision. Why does our Supreme Court have 9 justices? And do they ever or often have consensus, 100% consensus on all of their decisions? No, they don't. There's a variety of different opinions and thoughts that drive towards an outcome. And even at the most broad, if we think about our democratic institutions, elections. We go out to every eligible voter and we ask them what they think, and we group them geographically, but we can draw consensus and trust around what's the will of the people from a democratic standpoint by engaging with as many people as possible. And so when we think forward around AI and large language models, we actually have a whole variety of, a whole ecosystem, if you will, of different models that we can tap into. But the answers can be inconsistent, just like with people. But how inconsistent and how much is acceptable? So can I deploy an AI system where trust is less than 100%? And if the answer is yes to that, because trust is rarely ever 100%, to what level? 50% seems low. 90% starts to get into the range where, if I got a 90% answer, some situations it has to be 100%. I trust my pilot because she lands the plane 100% of the time, not 80% of the time. And so there's different scenarios, but I might trust someone to give me a good recommendation for a restaurant, and I might only have to have 20% trust in that. So it comes to a variety of different considerations. But in the realm of AI, there's really 2 things to think about as you're evaluating the different state of the art. One is this concept of hallucinations, where large language models make occasional mistakes due to the nature of how they're built and how that they source their own information inside the library. But the other is a lack of capacity. There's just things that at this current phase, the models that we're using cannot do. And it doesn't matter how you try to ask them or what information you give them, there's a fundamental capacity gap. So we have to understand which one we're dealing with, because you could go confer with a large language model and it could come back and give you an answer today and a different answer tomorrow, and that's really frustrating for people. So there is a way to establish trust mathematically, and this isn't in the realm of AI. This goes back to statistics, and there's something called a binomial formula. And if you create a scenario where across the top you have the percentage of trust starting from 10% all the way up to 100%, and then descending from 20 people down to 1, you create a mapping of how many people you need to confer with based on your level of trust. So if, for example, if I trusted this room of people to give me, if I trusted you all at 80% to give me a correct response if I asked you a question, if I were to go and ask 12 of you, statistically speaking, I could trust what the majority of you say 100% of the time. Even though individually I only trust you 80%, if I ask 12 of you, I could trust you, the results 100%. But as trust falls down to 70%, you'll see if you can squint that far all the way up at the top, even with 20 people at 70% trust, you never hit 100%. And as you go down the scale, if you trust at 50%, you can't break out of that box. And below 50% trust, the more people you ask, paradoxically, trust degrades. And so at 30% trust, I could ask one person, I could trust them 30%. If I ask 20 people, I trust them only 5%, because asking them in repetition actually drives the error rate out of control. And so we need to at least hit a threshold of 60% trust in the systems that we're using, or the people we're talking to, but let's talk about systems, to start to scale up, and then we would need to ask that in multiples. So that's a fundamental concept here. How many large language models are you interacting with? 1? How much do you trust it? You don't know. We don't know. And in every interaction, if you are talking to one, do you trust every interaction will be 100%? Probably not. So we do have a method here to get to 100% or close to. So we're going to introduce the concept of assistants and agents. And there's as many different opinions on this as there are people speaking on AI, which is a lot of people. But I like to think of assistants as the ones that you interact with on a human to AI kind of interaction plane. So I'm going to chat with you, you're going to give me an answer, but you have a set of skills and instructions and tasks that you're doing with me as the person. That's what most of us are familiar with at this point, and it's driven a lot through Bing, Copilot, ChatGPT, other things, is this kind of human-computer back and forth. That's been an entrenched idea in people's minds for a while. But now we're moving into agents. And agents are a little bit different. They not only speak to you, they also speak to each other. So if you think of an operating ecosystem, in the past you'd have a bunch of functions calling each other and passing data and retrieving data and processing data and then displaying it. So those would be through a series of functions. Now you have a series of agents performing that task. So they pass work, they can be arranged into an architecture, a workflow. They can utilize external data sets, and they can also integrate with your existing services. And so agents are going to be what the mechanisms by which we make large language models useful. And in this case, agents are how we can develop a trust framework to increase the amount of trust that we have in our large language models. So one of the large language models we interact with are quite good at many things, but there's some things that emerge which they are not good at. And there's something called the Alice in Wonderland problem, which is an interesting problem. And it's two sentences. Alice has N brothers, and she also has M sisters. How many sisters does Alice's brother have? And it's kind of a riddle. It's kind of a simple logic thing. And at face value, I had to pause and think about it for a minute before I could come up with the answer. So maybe really quickly, who thinks Alice's brother has M-1 sisters? Who thinks Alice's brother has M sisters? And who thinks Alice's brother has M+1 sisters? So about half the room raised their hand on the last one, and no one raised their hand on the previous one. So if I asked you, we'd have about a 50% belief that that's the right answer. And if you look at the thing down below, that is the correct answer. So from Alice's perspective, she has 2 sisters and a brother. From her brother's perspective, he has 3 sisters. So it's a different number. And so once you think through it for a second, it's quite easy. Large language models are not able to do this problem very well. So if we establish a baseline around trust, I've selected 6 models. There's more out there, but GPT-4 and 4o are on the left. Claude 3, they're 2 main Opus and Sonnet models, and then Mixtral 22 and 7. If you put them through the test and you do 100 interactions on this topic, they get a 37% success rate on GPT-4, a 51% success rate on GPT-4o, and a 7% success rate on Claude, and then nothing. You can ask them 100 times, they'll get the question wrong 100 times in a row. So they're very trustworthy from a consistent standpoint, but not trustworthy on the answer. Yeah?
Are you doing like a zero shot, or are you asking them to think through it step by step?
I've tried multiple models, multiple different ways, and I've even gone so far in some instances as giving them the answer in the question, and they still debate me on it endlessly. So even if you give them the answer, their logic takes them to a different conclusion that they believe M is the answer almost exclusively. So yeah, I've tried multiple different ones, but the experiment is based on the research paper that I showed, which was a zero shot. So what I've done is I've set up an experiment where we pick those 6 models, we run it through 100 interactions, and I build 3 agents to see if we can overcome this problem. Now, what seems to be happening is hallucinations on the 3 that are getting there. The first 2 from ChatGPT, they seem to be hallucinating a mix of different answers. And Claude seems to be hallucinating the right answer very rarely, and the rest of them are very consistent. So I don't know if you'd call that a hallucination or a capacity gap. But we're going to try to apply that binomial confidence framework and go through this 3 agent step. So agent 1 is going to look at the type of question. And this is really important, because if you want to get a good answer, you have to understand the nature of the question that's being asked. Agent 2 is going to take the 6 models and times it by 100 engagements each, so 600 interactions through to try to develop whether we can get the statistical average. Then agent 3 is going to actually identify the outliers screen out hallucinations based on statistical probability, and then flag for a human if the divergence is greater than 20%. So you can think about this as part of how you're building trust by doing that. So I'm not going to walk you through all of this. This is essentially just what I said on the previous slide. We're trying to eliminate hallucinations. We're trying to overcome some of the shortcomings. And so to do this, we create a set of prompts. We engage with multiple models, and we engage every model multiple times. In our case, 100 times. Every time you ask a question, we're going to ask it 100 times to see if we can overcome that. And then we're going to integrate human feedback and then have a feedback loop. So here's the 3 agents. So agent 1 goes and says, I'm going to screen the type of question so I know if this is an algorithmic question. Because the sense is that large language models don't do very well at algorithmic-based questions. So is it? And so what it does, it's the triage at the hospital. It's the receptionist who routes you to the right person. So the first agent is going to say, if you're a logic question, I'm going to route you to a different next agent versus if you're a guidance, an information, or an education. And so this is the role of what you can add very easily. And so I put in the prompt there. It's simply evaluating the question that you ask. You can ask any other question, and it will route you. And then it's saying, okay, the Alice in Wonderland question is a logic algorithmic question. Agent 2, in bulk, executes that question across as many different models as you want. On the screen, there's only 4, but that's just for display purposes. So I had 6 in this scenario, 6 models. And then you can drag the slider to 100 different answers per model. And then what you can see is, in this example, GPT-4 answering correctly on everything. And then 4.0, there's actually a mix of right and wrong answers. And then you have Claude, who in this instance has completely wrong answers for every single answer. And so because this is a logic problem, we actually give it a logic prompt before we pass the Alice in Wonderland. And we say, it's really simple, actually. The best way to do it is if you just say you want an algorithmic answer, nothing else. And that is a game changer for large language models to deal with this. Because when they start going down this long text puke narrative that they give you, ChatGPT always gives you a page when you ask any question, it tricks itself into the wrong answer. And so if you say, just simply give me write it like a formula, it almost 100% of the time gets the right answer, which spoiler alert. And then there's a third agent, and the third agent is evaluating for divergence in the responses. So if you look at the second column there, 4.0 and gave 2 different answers. It gave M and M plus 1. It flags what's the majority answer, so it did that correctly. So M plus 1 was the majority answer, but 40% of them were M. It was the wrong answer. And so it actually says flag for human review true. So it knows enough to ask for help when it doesn't have confidence in the level of the answer. But it's still giving us the majority answer. So any hallucinations are being screened out that way. So the results of this are quite profound. So we took something that is, through the research paper, unable to be achieved through large language models. We applied this 3-agent framework, and what we had was GPT-4 was able to hit 100%. 100 out of 100 answers were absolutely correct on the Alice in Wonderland problem. 4.0 was able to get 92% of them correct, but it rectified that to 100% on the third step. It screened out the wrong answers, and it didn't flag for human review because it didn't need to. It was within my threshold of hallucination, under 20%, so it was only 8%. And then you see actually agent 1, there's 100% almost in all of them where it was able to properly first classify the question, but on Opus and Sonnet and Mixtral 22 and 7, 0. Even with the correct prompting, they have a fundamental gap. So what we see here is GPT-4 hallucinating, and we see other models with an inability to do that even with the correct prompting and negotiation. So like I said, the power of assistance, there's Winnie the Pooh. You're braver than you believe, stronger than you seem, and smarter than you think. So that was my message back to GPT. It didn't think it could do this problem, but with the right coaching, it could. And I ran it well over 1,000 times to get my level of satisfaction. But it needed to be constrained. And this is where, when you're building these assistants and agents, you need a framework to test the environment and the prompts and the instructions you're giving it, and you need to be able to evaluate that before you go to production. You need to be able to say, this is a 92% response rate for this kind of question. And what I would say, but I didn't do in the experiment, was I would actually put in a safeguard going forward that it would stop. Agent 1 would actually say, you know what, I'm not going to pass this question on to Mixtral because Mixtral can't do these kinds of questions. So there's a branch but I can give you cooking instructions and it can give you guidance on filing your taxes or whatever, but it's not going to do that kind of question. And you can actually use this agent framework to stop certain branches of engagement where the model's not able to do that kind of work. Because the one thing that large language models never say to you, I don't know. They always try to answer, and that's their problem. They try to answer, and their answer is convincing, but it's not accurate. So now if we build in these agents who can just say, I don't have that capability, and I have the evidence now to prove that I don't have that capability, I'm not even going to attempt it, talk to a human or go use a different model. So in conclusion, the takeaway I want you to leave with, hopefully, is that you can apply this kind of thinking across multiple different models, and you can actually create a framework for your organization to establish a foundational level of trust in these systems that you can tell your deputy, you can tell your CIO, you can tell your business lead how much you trust them in the environments within which they're being deployed to. In 3 steps, we were able to establish a framework and test it and get the system up to 100% on something that had seemed like an intractable problem that multiple researchers were not able to overcome through the paper that was published. We needed to test multiple models in parallel to find the right fit for our use case, and that's really key here. And what's also quite interesting is that this isn't vendor specific. So once you have a set of agents that work together and you have the results data, that data can and should go out to other organizations if you choose as open source. So I could actually release this agent framework with the 1,000 run test data to prove that it's at 92%, and then I have a mechanism to get my answers to 100%. And then why not share that with other organizations? Because that's the only way we're going to build confidence in the system, and fundamentally that's the only way we're going to move towards a trust-based AI framework. So that was it. I know I went through that quite quickly because there was a lot to cover, but I'm happy to take any questions if you have any.
So as you build your AI platform or AI system, and we're getting people to change their understanding of, I'm not just dealing with an assistant, I'm actually taking AI, I'm integrating it into whatever my ecosystem at work, and you're getting these agents to sort of triage the question, bringing it through. How efficient is that? Does it take a long time for it to go through the framework? Is that a challenge today?
So in order to run the framework example that I use, it produces 600 prompts. It's all orchestrated and it executes in under a minute, and you get the results at the end. And so if you want to change the question type, or if you want to tweak some of the different system prompts that are guiding it, then you just do that and you run it again, you have your whole result set back. What is missing is the tools in which to do that. So what we have are a whole bunch of enterprise platforms, but they don't have this trust framework baked into them to know that if, Copilot's going to give me an answer, but it's not going to tell me how good the answer is, and I don't have any sort of objective way to measure it. So when you're doing your evaluation, I think you need to be subscribing to multiple different platforms to figure out, first of all, which one is going to fit your use case. And then the second thing, to the question that Anna answered around the number of iterations through, so 30, 40 different iterations and permutations to figure out how to build this thing. And it's not obvious, and so you need practitioners who can go forward and to test that for you. And that's the only way that you're going to reach that level of confidence. So this is part of the reason I wanted to come here, because this is something that I think that the GC community, the AI community, we should be doing it in an open and transparent way with each other, and then sharing. So if somebody writes a really phenomenal statement of work author for procurement, we should not only be sharing how we did that, we should be creating the sharing the agents that integrate, as well as the test results for confidence. So based on, my department could go and create a AI agent framework, and we could publish it and say, look, it's a 66% level of confidence that it's going to achieve this. And then if you come out and innovate, hey, I got it up to 75%. Well, we're going to all shift over and use yours next. And so I'm not aware of it yet, but I think that this is what we should be aspiring to do as a community. Any last question? Randy's going to pull me off stage.
Yeah. Is there any stuff like that going on, like on GCpedia or GC Connect or any of these groups? Like, is there anything going on internally, like where people are sharing this kind of stuff?
I think each community of practice, I think multiple departments are developing their community of practice. I haven't seen us merge into a hive mind yet around some of these things. Some are taking it very product specific. Some of them are taking it very, machine learning kind of route. I think that the opportunity now in front of us is to understand these base concepts and build that community of practice. I'm not aware that it exists in this format yet, but that would be what I think we should aspire to.
If anybody's interested